It gets kind of clunky when I show you pictures that look like this to describe electrochemical cells. Nobody likes drawing these. You certainly can't put them onto tests very easily without going to a lot of work drawing the picture. And instead, people have come up with a way of describing the cell notation so that you can be able to talk about whether something's the cathode or the anode, the direction the electrons flow in, the concentration of the solutions, where the salt bridge is, what the different electrodes look like. And that's this thing called cell notation. So right here, I am writing down for you cell notation. Notice it's very different from writing down chemical reactions. Like here's a chemical reaction that we just balanced of permanganate and iron in an electrochemical cell. As you look at this, you can figure out what's being oxidized and what's being reduced by taking a look at the oxidation numbers, but it doesn't tell you too much about the physicalness of that cell. This up here does. Even though they look very similar, they're actually quite different in terms of what they're supposed to tell you. This is telling you the stoichiometry. This is telling you what the actual cell parts are like. In cell notation, what is written on the left side is always the anode process. So this is my anode over here. And what is written on the right side is always my cathode. So obviously what's being written on the left side is the oxidation process. What's being written on the right side is the reduction process. Notice you wouldn't know that down here because the half cells are written such that you'd actually have to go in and look at the oxidation numbers to know this. But right off, I know that silver making silver ion is my oxidation process, my anodic process. My iron plus 3 making iron plus 2 is my reduction process. I can't balance this reaction, but at least I know what's the anode and the cathode. Notice that sitting right here in the middle is my salt bridge. Anytime you see a double bar like that, you know you have a salt bridge. So instead of seeing that double bar, excuse me, that hook right there, you see a double bar, and it's the same thing. It's my salt bridge. So here's my electrochemical cell. On the left side, the anodic process. On the right side, my cathodic process. Notice I'm able to write down the chemical species that are involved, not by having to write down the full half cell, but simply writing down the different species and their different oxidation numbers. Here's silver metal and silver ion, separated by 1 electron. And I can even write down the concentration of the silver ion. In this case here, it's 0.01 molar. So you can imagine that as you look at this system up here, that must be a silver ion solution. And the silver metal is serving as the electrode, and that solution right up there must be silver ion, and it must be 0.01 molar. But boy, wasn't it nicer and easier to simply write it this way here? Over here, I've got an iron plus 3, iron plus 2, and so this must be what is being reduced. It's 0.01 molar as I read it, making 0.1 molar there, so I've got my concentrations. But interestingly, I've got platinum sitting over here. What's this platinum right here? This platinum turns out to be my electrode, because if that is a aqueous solution, then it's not a solid. It can't be my electrode. That can't be my electrode. It's an aqueous solution. So evidently the wire which is sitting down inside here is my platinum. So I've got iron plus 3 and iron plus 2 in the solution and a platinum wire. Silver wire with a silver ion solution, platinum wire with a iron plus 3 and iron plus 2 solution. How do I separate and identify all of these? The single lines here, these single vertical lines here represent differences in phase or differences in the type of material that's in solution. So that line right there is a phase change separating silver ion from silver metal. That line right there is the phase change between the solid platinum and the iron plus 3 and iron plus 2. And then that line right there separates the two chemical species. So you ought to be able to learn to visualize in your head as you look at this. Anode on the left, anode on the right, salt bridge in the middle, the half cell reaction separated by a vertical line, half cell reaction separated by the vertical line, and the actual concentrations of the gases or the aqueous solutions also provided. Why do we write them like this? Well, this is called line notation. It keeps me from having to draw or photograph pretty pictures, and all of the relevant information I need is right in front of me. From that right there, I can tell you the anode and the cathode. I can tell you the signs. I can tell you the direction that the reaction is going in, the electrons are going in. So this is a nice, simple way of presenting it to you on the exam without having to do a lot of extra work.